Hey everybody, thank you for attending today's webinar. We are obviously covering weighted averages. This is going to be a pretty awesome webinar. There are a lot of things I want to teach today about how you can make weighted averages a little bit more manageable. I think generally when people think about weighted averages on the GMAT, they get a little nervous because you see it as only a high-level topic, but what I can tell you and what you're going to see today is there are ways of dealing with weighted averages that aren't necessarily going to be all that bad. So what I want to do is I want to start off with a fairly basic problem from a weighted average perspective, and then I want to teach you a few things that we could pick up or learn about weighted averages in general, and then of course continue to get into some harder and harder content. So the first question we are going to do is this question here, and I'll give everyone about 2 minutes, and there's a lot we can talk about once we start this question as far as basics to weighted averages. So as you guys get to your answer, put it into the public chat box from there. Okay, so this was about 2 minutes, and I imagine most of you who are familiar with weighted averages probably were okay with this question. And what's going on here is we're being asked, we're being given that it took 100 students 800 days to complete their master's, and also 150 students 600 days to complete their master's. We need to come up with the average number of days that the students took to complete their master's. So what we have is we're trying to determine the weighted average. Now remember, the way weighted averages work is there's usually some sort of quantity, which doesn't have to be in the form of actual integers. We can have percentages or fractions, etc. And there's some sort of statistic. So in this question here, what we're seeing is we have 100 students times 800 days. And keep in mind, I don't normally put the units there, but I'm going to show you why I'm doing this in a second, plus 150 students times 600 days. And what most people struggle with here is they always question, what they should divide by here. Should we divide by the days or we should divide by the students? Now, what you're going to notice is that we're left with days in our answer choices, which means we want to divide by students. So we see we have 100 students who do 800 days and then 150 students who do 600. So what we have is 250 students. What you'll notice is that this value of students, or the unit of students, cancels out across the board. Notice we're ultimately left with just days. So if we do the math here, we have 100 times 800. That's going to give us an 8 with, as you can see, 4 zeros, so that's 80,000. Plus what we have is 90,000 for the 150 times 600 days. And we're going to divide by 250. Now, one thing that I like to do, if we're actually doing this all the way out, we say, 170.
Hey, John.
Oh, hold on, guys. We've got... All right, I think we're good. Sorry, someone was on... You know what, everyone, if you're on the call, just make sure you're muted. Some people are getting unmuted. Sorry about that. So we have 170,000 divided by 250. And one thing I like to do anytime I have, somewhat large math with the zeros is I like to reduce the zeros down. So then that gives us 17,000 divided by 25. And of course, we don't have to do the long division all the way out, but when you do, you get 680, which is of course 680 days. Now, to me, this is probably the most systematic or black and white weighted average that you're probably going to see. And something kind of interesting that I want everyone to start focusing in on, or being able to hone in on as far as weighted averages are concerned, is that there is a level of estimation that can always be used when you're dealing with weighted average questions, because essentially everything is weighted. So let me just give everyone a really quick example, and then we'll come back to this problem, and we're going to do some other problems where we can deal with estimation. But let's say we had 100 people, in a room, and let's say we're talking about men and women. And let's say 99 of the women, their average age was 31. And let's say one man, the average age is 25. Well, if we were to do the weighted average out here, we would be able to say right away that the weighted average is going to be closer to 31 than 25. Now, based on how weighted averages work, because there are many, many more women and their age is 31, and there's only one man, the average weight is going to have to be closer to 31 because that's where the higher quantity is rather than 25. So essentially, if we go back to this question here, which is, the question we just did about the students and the days, we'll notice that 100 students took 800 days, whereas 150 students took 600 days. So because 150 students is greater than 100 students, the weighted average is going to have to be closer to 600 than it would be to 800. So we can automatically remove 700 days, and we can remove 720 days because those aren't logical answer choices. Now, of course, then we have to balance it out between A, B, and C, so we don't have an exact answer there. But again, these are skills that you can take if you have to take a guess on the GMAT and you have it set up, or you can tell where this thing should be weighted towards. At least you're giving yourself a better shot at getting this right than just taking a wild guess with no added information. So the answer here is 680, but what I want to do is I want to kind of test this theory out. And for those of you that were able to listen and follow what I just showed you, I want you to take this idea and I want you to apply it to another weighted average question, and you'll notice a very key word in this question. So let me put it up here. So this question, you'll notice we use the words closest to, and closest to obviously implies estimation. The GMAT loves that. So what I want everyone to do here is I want you to use estimation here, see if you can come up with the right answer, and then we'll talk about it. So I'll give everyone about 2 minutes here. Okay, so that was again about a little over 2 minutes. So one of the things we can do here, we can set this up. I mean, whether or not you feel comfortable doing this in your head is obviously something that everyone is different in regards to. I would say personally, I at least like to get pen on the page, get some work on my paper so I can kind of analyze it from there. Generally, looking at things off the screen, which you're generally doing when you're taking your GMAT, is tough because you're trying to organize all that information in your head. So what I see here is that when we're dealing with stock A, we have 50 shares of stock A, which earns 10 cents, plus 100 shares of stock B, which earns 20 cents. And we're saying which of the following is closest to. So of course, we'd be dividing it by 150 shares. Which of the following is closest to the investor's average, or in other words, the weighted average? So right away, we see that we have more of the 20-cent stock than we do of the 10-cent stock, because there's 100 shares versus 50. So right away, the weighted average is going to tip towards 20 cents. Doesn't mean it's going to be 20 cents or 20 cents per share, of course. It doesn't mean it's going to be 20 cents, but it's going to be closer to it. 15, of course, would make it so that we had an equal number of 20-cent shares and 10-cent shares. So we know that anything 15 or below is out. So here's what we're left with. We're left with either 17 cents a share as the weighted average or 19. And this is where, you know, with practice and a little intuition, you're going to be able to get these right. You know, when you think about 19 cents a share, that's quite extreme because the boundaries that we're dealing with here are anywhere between 10 and 20 cents per share. Now, we already said that there's no way it's going to be 15 or lower because we know that we have more 20-cent shares. So the reality here is that 19 is a bit extreme because we do have 50 stocks worth 10 cents per share versus 100 of 20 cents per share. So the most logical answer here is going to be not 19, certainly not 15, somewhere in the middle of that, which is 17 cents per share. And what you'll notice in a question like this is that this question was actually designed for you to be able to come up with a logical estimated guess. Not every weighted average question is going to allow for that. So, you know, sometimes you may have to do it all the way out, but this is why reading your questions so carefully are important, because if you see the word, you know, estimated value or closest to, you certainly will know that estimation is going to be a big part of what it is you're doing. So the next thing I want to do here is a data sufficiency question that's actually similar to some of the things we've already started. So I'll give everyone again about 2 minutes and then we can talk about it. Okay, so this is a really cool question. I can tell you that, you know, this is a type of question the GMAT does like to ask about. You know, obviously, like anything, you don't know if you're going to see it, but it's something that they do like to test on because it's something that most of us never really learned back in high school when we learned this type of math. At least, you know, I don't recall this ever being a big part of, you know, weighted averages when I learned them. But I can tell you that it's actually a very logical skill that they're testing on. And once it clicks, you're going to see right away that it's not all that bad. So there's always boundaries to weighted averages. So let's go back to every question we did at this point. In this question here, the boundaries of the weighted average is that the weighted average is going to be somewhere between 10 cents a share, and I'll highlight these, 10 cents a share and 20 cents a share. It has to be, because that is the statistics that we're going on. We have 50 shares of something at 10, 100 shares of something at 20. It would be impossible for the weighted average to be like 30 cents a share, because that's well above the maximum per share value of 20 here. When we go to this question here, we know that the weighted average is going to have to be somewhere between 600 days and 800 days. There's just no other option there, and those are the boundaries. So when we go to a question like this, right away we see that the question is saying, do more than 15% of the students in the group use laptop computers? Now, that is all. We don't have any given information besides the fact that we're dealing with freshmen and sophomores, and that's it. That's the pool of people that we're working with. Right away, you can see that this is probably going to be a 50-50 question, which, as I've told everyone before, it basically means that the answer is going to be either C or E, because only knowing that 15% represent the sophomores is certainly not helping, because we care about the total group, which consists of sophomores and freshmen. So 10% just being freshmen in statement 2 carries a similar issue that we don't know anything about the sophomores. So right away, we can say to ourselves that we're going to be analyzing these together. Now, what we should notice here is that when we're looking at our statements together, we should be able to say that the weighted average is between 10 and 15%. Because remember, we know we're only dealing with freshmen and sophomores. And a lot of people, when they look at this question, a lot of students, they say E because they say, well, how many freshmen and sophomores do we have? How do we know if it's greater than 15% or not when we don't know the quantities? But what's really important here is you don't necessarily need a quantity to deal with a weighted average, and we'll get to that in a second. What you do need to know in this case, and remember, we're not even solving for what is the weighted average. We're solving for, do more than 15% of the group use laptop computers? Now, had they asked for what the weighted average actually was, then yes, I agree with anyone who put E here that we wouldn't have enough information. But because we're given that the sophomores are 15%, the freshmen are 10%, we know with certainty, 110% certainty, that the weighted average is going to be between 10 and 15%, 15% being the absolute max. So when the question asks, do more than 15% of the students use laptops, we can say with certainty that the answer is no, and that gives us an answer of C as in cat. So this is a really cool question. Anyone who struggled with this or didn't see it right away, get this idea down on a flashcard because it's going to be incredibly, incredibly helpful for you. So to kind of harp on the idea of weighted averages with percentages, I want everyone to do this next question here, which is a weighted average with a percent. And as usual, I'll give everyone about 2 minutes, and we'll talk about it from here. All right, so that was about 2 minutes there. So this is an interesting question because what you're going to notice is there's actually no quantities here, but yet we're able to come up with a weighted average. Now what we should note is if you add together 30%, 50%, and 20%, you're left with 100%. So really what we're dividing by is 100%, but remember, if you get rid of the percent sign in 100%, that's actually the equivalent of 1. So really dividing by 1 isn't changing anything. And so all we're really doing here is we're saying that 0.3 times 4 plus 0.5 times 50, excuse me, 0.3 times 40 plus 0.5 times 50 plus 0.7, excuse me, 0.2 times 70. And if we do that out, we get 12 plus 25 plus 14, 25 plus 16, or excuse me, not 16, 25 plus 26, which is 51. So again, if you wanted to plug in a real number for the group of students, you could have. You literally could have plugged in any number that you want, but you would have gotten the same answer. So I always prefer, if I don't have to plug in a real number, I don't want to use it. Now, the next thing, I kind of want to flip things around a little bit, and I want to do some average rates. There's a really cool question that I do with almost all of my advanced students that I work with that has to do with weighted average with rates. Most of the students I show it to end up getting it wrong. And so to help kind of pad that, I want everyone to do an average rate that you're very familiar with, which is going to seem out of place for what it is we're covering right now. But if you guys give me a few minutes and another question after this, everyone is going to kind of see the point of what I'm doing. So without me giving too much away, I want everyone to attack this problem in any way they see fit, and then we'll go from there and do another problem. Okay, so it's about 2 minutes. Now, some of you may be wondering why I just threw an average rate at everyone. Because this problem is actually a component of our rate times time equals distance chapter. What's interesting about this question, though, is that it's a weighted average. It's a weighted average, and the way in which we teach it, we almost forget about the idea that this is a weighted average because we're so focused on having the formula memorized that average rate is total distance over total time. What that means is that the average rate is weighted by the time. But again, we don't set this up like a traditional weighted average or anything we've done up to this point, at least the way that I teach our students, my students to do it, and we teach our students to do it, is we just set up a very simple chart. And we have a rate, an R, a T, and a D. And remember, average speed is total distance over total time. Now, we label our rows as going to and coming from. And we see that Melissa is going to at a rate of 4 and coming at, or going from or back at a rate of 10. Now, like many average rate questions, this problem doesn't give us what the distance is. But we do know that she's going the same route to and from school, so we can label the distances to be the same. At this stage of the game, if you want to put in a real number for distance, you can. Generally, as I said earlier, I like to just use variables. So our time, which is, of course, distance divided by rate, is d over 4 and d over 10. And then we simply plug in. Total distance is going to be 2d. Total time is d over 4 plus d over 10. So if we get common denominators, we have 5d over 20 plus 2d over 20, 2d all over 7d over 20. So if we flip and multiply, we get this. We see the d's cancel. 40 over 7, which is 5 and 5/7. Now, I'm showing everyone this for a very, very, very specific reason. And in my opinion is, had I not, I think some of you might get the next question wrong because of how you attack it. And I think that's a really important part of dealing with these questions is, of course, attacking them in the right manner. So with that said, and without telling everyone anything more, I want everyone to take a stab at this question here. And when you get the answer, definitely make sure to put it into the chat box. So I'll give them about 2 to 3 minutes. All right, so that was a little over 2 minutes. What's great about this problem, if we're looking out for it, is that we should recognize right away that this is a rate question as well, but it's in miles per gallon. So instead of the average being total distance over total time, the average is total distance over total gallons. So instead of miles per hour, where hour is a time, we're saying miles per gallons, where gallons is some sort of an amount. So really what happens here when we set this up is we're making the same table, same exact table, but we're just changing what we label it. Instead of rate time distance, it's rate gallons distance, and we're filling in. Now notice we have two categories. We have what happens at 10,000 or 10K feet, and then we have what happens at 20,000 or 20K feet. So we fill in, it's that simple. So a plane can travel 200 miles on 50 gallons of jet fuel, and it can travel, that's the rate. So yes, that's the initial rate that we're given. So if it's saying that it can go 300 miles on 50 gallons, that's obviously 200 miles for the distance, 50 gallons for the gallon, so that's 200 divided by 50, which we'll do off to the side here, 20 divided by 5, which of course gives us 4 there for the rate. And it can travel 300 miles on 50 gallons of fuel, so 300 divided by 50, of course, is 6. So the rate of the plane going at 10,000 miles above the Earth here is, or at 10,000 feet, is 4 miles per gallon. And if it's going 20,000 feet, 6 miles per gallon. Now, we keep going here, and it says, which of the following is the closest to, so once again, notice we're doing a little bit of estimation here, the number of miles per gallon the plane will average if it flies for 1,000 miles, okay, at 10,000 feet, and 3,000 miles at 20,000 feet. So what we have to do here is we once again need to strategically get our gallons, and unlike the last problem, we have all that numerical values here, so we're going to be able to do this out. This gives us 250 gallons at 10,000 feet, and then of course 3,000 divided by 6 gives us 500 gallons. So now when we plug this into our formula, total distance over total gallons, notice we have 4,000 divided by 750. Now, of course, we can do a little reducing if we want to. I mean, we can make it 400 divided by 75. And when we do the math all the way out, we see that our answer is about 5.33. Now, as I said, they allowed you to use estimation here. You need to use that to your advantage, and you get an answer of C. For any of you who did this a different way and you set this up more like a standard weighted average, the best thing I can tell you about this type of problem is if it walks like an average rate and speaks like an average rate, it is an average rate. I don't care if we're talking about miles per gallon or if we're talking about, miles per hour. It's still an average rate question. So my suggestion to everyone here is set this up as if you are setting up and doing a regular average rate. Trust me, it's going to pay wonders for you. As you can see, my thought process, although everyone probably looked at this question as much easier, my thought process here with the Melissa problem was no different than the plane problem here. So if everyone can kind of take this idea to the bank with them, if you see it on the GMAT, I'm confident you will be very successful with it. So what I want to kind of wrap up our webinar with is I want to start talking about now about different ways a weighted average can be quote unquote weighted. Now we've already talked about the idea that A weighted average can be done with percentages. We've certainly seen quantities and numerical values. So now I want to get into a couple other concepts that I think are going to help a lot, especially in data sufficiency. So I'm going to give everyone 2 minutes to work on this problem here, and we're going to explain a concept that is going to arise in this question here. So I'll give everyone about 2 minutes. Okay, so that was about 2 minutes there. So the good thing about what I'm about to show you is that I'm not reinventing the wheel in any way. I'm going to set this up exactly how we've set up a lot of our weighted averages here, with the caveat that we're using some variables. So A is going to stand for the number of children in classroom A, and B is going to be number of children class B. So what we can do for setting up our weighted average is we can say 100A plus 160B over A plus B equals 120. 100A plus 160B equals 120A plus 120B. And then we kind of combine a little bit so we can bring the 120B over, the 120A over. We get 40B equals 20A. And of course, now we can divide everything by 20, and we get 2B equals A. Now, this is where a lot of students really make mistakes, not just in this question here, because we don't have that trap answer, but in other questions that I've seen on the GMAT involving ratios. The one thing that you don't want to do if you get to this part, and let's say answer choice F was a 1-to-2 ratio, when it's saying the ratio of the number of students in A to B is what? What they're really asking is, can you isolate A over B and make it equal to something? And the answer is yes. And if you do this effectively, life will be good. But if you stop here, there's a high likelihood that you may choose answer choice F, which I realize there is no F on the test or, on any GMAT test, but that's the answer you're highly likely to choose. So what you need to do is you need to divide both sides. You need to divide both sides by B, so you're left with 2 over 1 equals A over B, and that's your answer. Now, there's something incredibly interesting here that can be applied to other problems and especially data sufficiency questions. That interesting thing is that we took the two statistics of the IQ being 100 in classroom A and the IQ being 160 in classroom B and a weighted average and got what we called the weight ratio. That's the weight of the children in classroom A versus classroom B. The ratio is 2 to 1. So if we kind of flipped all of this around, and let me get rid of some of this stuff here, except for the bottom part. And if we didn't know what the weighted average was, so let's just pretend we have no idea what the weighted average is, but we know that the weight of the students from A to B is 2 to 1, which means we have the equation that 2B equals A. Well, we can set up this formula, and you're going to see that we actually end up obtaining a weighted average here. So we can say 100A plus 160B over A plus B equals what? Now, take 2B equals A, we plug 2B in there, we plug 2B in there. So what we have is we end up with 200B, because that's 100 times 2B, plus 160B equals 2B plus B, which is 3B. And like magic, we get 360B over 3B. The B's cancel, and lo and behold, we have 120. So on a higher scale or a higher level, what does this tell us? It tells us that if we have the weighted average, if we have the two statistics like 100 versus 160, and we have the weight ratio or the weight in some way, we can come up with the weighted average. This is super powerful stuff because what the GMAT can show you, like in this case, is a data sufficiency question, like what I'm about to post, which is this here. So I'm going to give everyone a few minutes, and we will then talk about this and kind of wrap everything up from there. So everyone take a look here. Okay, so that was about 2 minutes there. So for those of you who were successfully following what I was doing in the last problem, we see that we don't have to put too much work in here to get this answer. So what we're given right off the bat, if we're going to call student tickets, you know, S, and the number of other tickets we'll call T, is that we have 20S plus 20T over T plus S equals what? So we need the weighted average. When you go to statement 1, you just see that S is greater than 100. Now, obviously, that on its own can't do anything because we don't know anything about T, and we actually don't really know anything about S. But when you go to statement 2, based on everything that I just taught everyone, if you set up this ratio, we have student tickets to other is 9 to 5, or 5S is 9T, or S is 9T over 5, we see that we can successfully plug this in here, and ultimately all of our values will have a T in it, the variables will drop, and we will get a weighted average. By being well-versed in this idea, it saves you the time, effort, and energy in a problem like this to have to plug in 9T over 5 for S. Sure, you can do it, but it's data sufficiency. Like, we don't want to waste time that presumably we don't even have. So if you can see a question like this, and you can get it right in 20, 30 seconds because you know this principle, and you know those who don't know it are either A, getting it wrong, or B, are taking a long time, you're going to be money on a question like this, and it's going to go a long way for your test, and it's going to go a long way for your confidence as well. So this is just a little insight onto some of the things that you should know from a weighted average perspective. Hopefully, if you guys thought that these were scary questions before, you see they're not. Everyone else who's here, I just wanted to let everyone know that we just partnered with Beat the GMAT, so we have a lot of cool reviews on their site. So we just posted that in the chat box if anyone wanted to take a look, and we have a discount on their site as well. So thank you again, everyone, for coming. Just to let everyone know, we won't be having a webinar next week, but we'll be back to our regular schedule after that. And if you can, please fill out the feedback form so we know that everyone's happy with the topics and the way that we're presenting our webinars. So if anyone has any questions, issues, concerns, feel free to reach out to Scott or I as always, and we'll see everyone in a few weeks.